2.6 Systems of Equations. We're going to solve 3x3 systems and more. So first off, there's one that's already solved. We want to determine if that ordered triple. Since now we're dealing with 3 variables and 3 equations, we want to see if the ordered triple is a solution. So, step 1, plug in the x. The first number is x, the second number is y, and the third number is z. So let's try the first row. If I plug in 1 for x, so 3 times 1 plus 1 plus 1, does that equal 5? Well, 3 plus 4 plus 1, that does equal 5, so it checks on the first row. On the second row, if we plug in 1 for x, so that'd be 4 times 1 plus y, which is 1. Then it says minus 2z, so minus 2 times 1. Does that equal 2? Let's check and see. So it's a question mark here. So that's 4 plus 1 is 5. 5 minus 2, that's 3. So no, it does not equal 2. So we can move on. That one's a no, this is not a solution. So we can go on to the next question. On this one, if we plug in 0, 3 times 0 plus 2 plus negative 1, does that equal 1? 0, 2 minus 1 is 1? Yes. Now if we try the second row, 5 times 0 plus 2 minus 2 times negative 1. 0 plus 2, that's plus 2. 2 plus 2, that does equal 4, so that one checks. And on the bottom row, there's no x to plug in, so 3 times the y, which is 2, plus 7 times the negative 1, which is 6. 6 plus negative 7, which does equal negative 1, so this one is a yes. On the number 2, we have 3 equations, but the very bottom equation, if you notice, that they've told us what z is. So I'm going to go to the middle row that only has 2 variables and plug in that z. So y minus 3 times z, which is 5, equals negative 14. So y minus 15 equals negative 14. So we add 15 to both sides, and you get y equals negative 15. Negative 14 plus 15 is 1. So now I know y is 1, z is 5, I just need to find x. So we go to the top row. I don't know x. I do know y is 1, because we just solved that one. And then plus 3 times z, which we already saw was 5. And then that equals negative 20. So that's x plus 7 plus 15 equals negative 20. Combine like terms, and you get x plus 22 equals negative 20. Subtract 22 from both sides, not 20. Subtract 22, come on, minus 22, and you get x is negative 42. So my solution, the ordered triple, is x, which is negative 42, comma y, which was 1, comma z, which is 5. Moving on to number 3. On number 3, I see 3 equations, and I see 2 variables on each equation, but if you look, there are x, y's, and z's. So step 1, I need to get rid of at least one of the letters. So the first one I notice right off the bat is the bottom one. If I add these 2 rows together just like they are, if I take, I'm going to move this one over here so you can kind of see, y plus z equals 7, and I'm going to take x minus z equals 2. If I give a little space there, now when I add, x plus nothing gives me x, y plus nothing gives me y, but z plus negative z goes away, and we get 9. So I have x plus y equals 9. Well, that gives me an equation with an x and a y, and the top row had an equation with an x and a y. So if I take those 2 equations, and I'm going to write them over here, let's go to a different color for now, and say x minus y equals 9, that one, and then bring this one over here, x plus y equals 9. Now I've already got a positive y and a negative y, so they're set up for elimination, so I can add these 2 together, and we get 2x plus no y's equals 18, divide by 2, and we get x is 9. So now I know the only variable I know is x, but I can go back to any one of these. Let's look at the ones that have an x. X minus y, x plus y equals 9, or x minus y equals 9, doesn't matter. I can now find out what y is. So if I put in x minus y equals 9, the original first equation they gave us, if I plug in that x, 9 minus y equals 9, subtract 9, I get negative y equals 0, divide by negative 1, y is 0. So for my ordered triple, I know x is 9, y is 0, but I have a third one, z, so I have to find z. So we can use either row, the bottom, well, let's use the middle row. Y plus z has to equal 7, and we know y is 0. 0 plus z equals 7, which means z equals 7. So 907 is our solution. On number 4, when I look at number 4, I notice I have 3 equations, and I have x, y, and z on the first and third row, but only x and z on the middle row. So since this one's just x and z, I'd like to eliminate the y. So I'm going to take the first one and the third one and get rid of the y. So to get rid of the y, I see this is a 2y. If I multiplied this top row by 2, let's give you a little bit of line here. If I multiply the top row by 2, then I'd have a negative 2y and a positive 2y. Then that would eliminate. So let's do that. So that becomes 2x minus 2y plus 6z equals times 2, 8 times 2 is 16. And if I take the bottom row and add that to it, I already have x plus 2y plus z equals 8. And now if I add these two rows together, I get 2x plus 1x is 3x. The y's go away. And 6z plus 1z is 7z equals 24. So they didn't solve it for me. But if you take what we already had, the middle row, and put it right here. I'm going to rewrite these where I have a little more room. So 3x plus 7z, this is the one we just solved. This is the one right above. And take the new one, we have 3x plus z equals 6. I now have a system of equations with two variables, and they're actually the same number in front of the x's. If I multiply by negative 1 on a row, so let's take the bottom row, negative, negative, negative. Now I can add these two rows together and eliminate my x's. 3x and negative 3x goes away. 7z plus negative z is 6z, and 24 plus negative 6 is 18. Divide by 6, divide by 6. We've just solved for one of our three letters. Z is 3. Now, which row? Since we have z, I don't want to do one that has x and y, but if I look at the middle row, we had 3x plus z. Well, z we know is 3 equals 6. So I can solve for x now. Subtract 3, subtract 3. 3x is equal to 3. Divide by 3, divide by 3. X is equal to 1. So in my ordered triple, I know x is 1. I don't know y, and I know z is 3. So let's find y. So let's take, it doesn't matter, one of the equations that has a y. So the first or the third row. Let's use the third row because I don't see any negatives on that one. So plug in the x, which is 1, plus 2y, I don't know what that is, plus z, I do know what that is, 3, equals 8. So combine my like terms, and we get 4 plus 2y is equal to 8. Subtract 4, subtract 4. 2y is equal to 4. Divide by 2, divide by 2. Y is equal to 2. And we're through with the front side. And I forgot to turn my page before I maximize the screen. So turning the page, whoops, wrong screen. On the back side, let's talk about a little calculator tips before we move on, because I had to start my calculator while I pause the video. But on the Inspire, you can actually solve a system if it's linear. So on the Inspire, if you go to a calculator page and you press, and I didn't mean for this to be maximized, I thought I had it fixed a second ago. You press Menu, and we choose Algebra. Number 2 says Solve System of Linear Equations, and you can tell it how many, if there's two rows, 2 equations, and how many variables. So let's look at the next one on this assignment that has 3 rows, so I see 3 equations. So if I go in the calculator and say, I want 3 equations, and you hit Tab, it'll automatically put X, Y, and Z. we just type in our equation that was on the other page, and I've got to go back and forth now. So x plus 2y plus z equals 3. So I'm going to type that in. X plus 2y plus z equals 3. That's the first row. The second row said 2x minus y plus 2z equals 6. So 2x, oops, I forgot to press enter. Oh, my bad, I thought I did. Equals 3, and oh, tab would be better than enter. Don't hit enter. Second row was 2x minus y plus 2z equals 6. And let me press tab to get to the new row, or I can move my cursor, but it's already down there now. And the third equation is 3x plus y minus z equals 5. 3x plus y minus z equals 5. Let me double check my whatever. 2x plus 2y plus z equals 3. 2x minus y plus 2z equals 6. And 3x plus y minus z equals 5. You press enter. Here's x, here's y, here is z. So our solution is 2, 0, 1. So 2, 0, 1. Or sometimes you might write it x equals 2, y equals 0, z equals 1. The answer can be in any order. Okay, let's move on to the last one. So, on this one, on an 18-hole golf course, there are par 3 holes, par 4 holes, and par 5 holes. So I notice there's 3 variables. So I'm going to let par 3 holes be my x, par 4 holes be my y, and par 5 holes be my z. And they tell us there's 18 holes. So x plus y plus z has to add up to 18 holes. There's one equation. Now, we know a golfer who shoots par. So he shoots 3 on those holes and 4 on every y hole and 5 on every z hole. He gets a score of 71. So that's our second equation. 3x plus 4y plus 5z equals 71. And then the next sentence says the sum of the number of the par 3 holes, that was our x, and the number of par 5 holes, which is our z, is 11. And how many of each type are there? And you can type this in on the calculator and do what we just did on the last one. So let's do that. Menu, algebra, solve system. There's 3 equations. If I hit tab, it automatically puts x, y, z. My first equation was x plus y plus z equals 18 holes. Tab to get to the next row. 3 for every par 3 hole, plus 4 for every par 4 hole, plus 5 for every par 5 hole, and the score would be 71. And then the last one, the par 3 holes plus the par 5 holes, the sum of those was 11. And 6 par 3, 7 par 4, and 5 par 5s. So 6, 7, 5 is the ordered triple, which means 6 par 3 holes, 7 par 4 holes, and 5 par 5 holes. And there's how you solve systems. The rest of the assignment are review problems that have used anything we've done up to this point.